This is an interesting manufacturing or maybe mechanical engineering type problem. You're designing a walk that's a portion of a sphere, only it has handles on it, but we won't count those. And it has a radius of 16 centimeters. That's the radius of the sphere. And the walk is only to be 7 inches or 7 centimeters deep. Find the volume of your walk. So in other words, we want to find the volume of some bottom piece of a sphere. So for simplicity's sake, and engineers always do this, put the origin at the simplest place, which is the center of the sphere. Then the equation of the circle whose rotation about the y-axis will make the walk as x squared plus y squared equals 16 squared. Right? That's a circle with the radius 16 center at the origin. 16 squared is 256. So if we wrote it as a function of x, it would be x equals square root of 256 minus y squared. I guess that's a function of y, sorry. Oops. That's x as a function of y, so x equals square root of 256 minus y squared. Alright, well, I took the liberty to draw a picture of that circle, and here is a picture of that circle. When we rotate that circle about the y-axis, we make this little bowl-shaped object like the walk. And so what is the volume of our walk? Well, there's some tricky parts to this, but you should recognize that we need to add up all the disks between, careful about this one, -9 to -16. Why do we have to go from -9 to -16? Remember that the depth of the walk was 7 centimeters. And because of this walk, I guess I drew it at the bottom. I could have drawn it at the top as well, but I drew it at the bottom, so I'm stuck with it now. Let's stick with it that way. Pictorially, it would look like that. So these are 7 centimeters apart, -16 to 9. Pi, of course, I take a sample disk, and the disk's volume is pi times this radius squared, where the radius is as a function of y, x equals square root of 256 minus y squared, but then we want to square that radius, times the thickness of the disk, which is dy. And so I think you can see why that is the formula that gives us just exactly the volume we seek. And it turns out that when you square the square root, then the integration becomes real nice. The integration of 256 minus y cubed over 3. And we need to evaluate that at -9. Subtract the answer when we evaluate it at -16. And so here that part is worked out in somewhat gory detail, I suppose, because -9 times 256 is -2304. I just left that as 9 cubed, and I made it a plus because -9 cubed is negative, and negative of a negative is a positive. So that's 9 cubed in my mind is 729, but we'll let that go for now. 729 over 3 is like 243 or something like that. So, but we also have minus -4096. That's 256 times -16. So minus -4096 plus 16 cubed over 3. Well, that's not going to be quite as nice as the other one. But nonetheless, we can do this part. This is negative. This 4096 is positive, and when you subtract, you get 1792. And then this, as I said before, is 729 over 3. That's 243. You could actually work this out with powers of 3. That's 3 to the 9th divided by 3 to the 1. So that's 3 to the, wait a minute. That's 3 squared. No, sorry, that's 3 to the 6th divided by 3. So that's 3 to the 5th, and 3 to the 5th is 243. So we also had to subtract minus this, so subtract that 16 cubed over 3. And trust me, you can do this arithmetic on a calculator if you have to. It turns out to be 2009 times pi over 3. And of course that answer would be in cubic centimeters, because centimeters was the way our measures were given. So we'd like to say, well, how much of a liter is that? Well, if you multiply this all out, it's just slightly more than 2009 cubic centimeters, and since 1 cubic centimeter is 1,000th of a liter, the wok holds approximately 2 and a little bit of spare change liters. So if you work this out, divided by 1,000, that's how many liters your wok holds.